So what's a direct linear relation? Well, we just talked about this. It's always y compared to x, always. That's how you write the title. And the two key features to that graph are it's a straight line and it goes through the origin. That's the key. And I like that Brendan said, rather than saying straight line, you said it's a constant rate. And that's really important for any type of linear graph. So today, that's direct. Today we're going to be looking at partial y compared to x. And the question is, what does that graph look like? That's what we're learning today. And the math will get just a little bit more complicated than it was last week. So we're doing two examples. A magician has the following booking fee schedules for his shows. So you phone this magician up, you say, well, I want to book you for a show. What's it going to cost? This person does staff parties and birthday parties and all kinds of stuff. And the magician tells them, well, it's always $50 per show. It doesn't matter how long the show is, you're going to pay me $50. It's what we call a flat fee or a fixed amount. And the person says, well, you mean to tell me if it's a 1 hour show, it's $50, and if it's a 2 hour show, it's $50? And the magician says, no, not quite. It's not that simple. It's $50 per show, and I'm going to charge you $25 for each 15 minutes. And you should make a note here. This says every quarter hour. A quarter of an hour is 15 minutes. Okay? And it's probably going to be easier for us to work in minutes. So the first thing we're going to do is complete this table. And this is a little bit different than the amount of flour and cookies. It's a little bit different than the number of logs and the mass of the logs or the weight of the logs because of that fixed amount. So if it's 15 minutes for this one, the magician is going to charge the people $50 plus $25. At $50, that's a flat fee. Why does the magician charge that? Well, you know what that might be? That might be travel costs. It might be supplies that he needs no matter how long the show is. There are some fixed things that he needs to cover. So that gives us $75. And I've already got the dollars here in brackets beside the fee for the show, so I don't need to write dollars each time. Now, I could do the same thing here for this next one, right? I could say, well, it's going to be $50 plus, well, this right here, this 30 minutes, everybody, is two 15-minute time slots. So it would be plus 2 times $25. And I'm asking you to work out what that is. You get 100? 2 times 25 is 50, plus the 50 is 100. Now, I have a question for you. Did we really need to do this? Did we really need to write this to figure out that the next one is $100? Or was there a shortcut we could have taken? Yeah.
You could have added an extra 25 to the previous.
Right. Now, I'm going to erase this so that we can show everybody what it is we're talking about. Why are you saying that this has to go up by $25? You're right. Why does it have to go up by 25?
Because it's going up by another 15 minutes, so that's another $25.
Right. We've set up our table here so that this is going up 15 minutes. Whoops. And we know that for each additional 15 minutes, it goes up 25. And what we're getting at here, Brennan, is that this is a constant rate. We keep going up 15 minutes each time, always up by 15 minutes. And what happens is this always goes up by 25. This is what makes it linear. This is not going to be a direct linear relation, But what makes it linear, and we did this with the cookie problem, we went up, I think it was 20 grams of flour, and we got 5 more cookies. I don't remember exactly what it was. But as the number of cookies went up, the amount of flour went up. And if the number of cookies went up the same amount each time, the amount of flour went up the same amount each time. As the number of minutes goes up by 15, the money that they're going to earn is going to go up by 25 each time. And again, I'm just going to put up here to make sure if you're looking back and you're wondering where these numbers are coming from, this 90, 105, and 120, it's that a quarter of an hour is 15 minutes. So we're going up by 15 minutes each time, $25 more. Okay. Do you have in your table a 0? You don't. Okay. Good. We're going to make a graph in a bit, but what's the dependent variable and what's the independent variable? And the reason why we need to know which is which is you need to know which is which because the dependent goes on the y-axis, always. And if you don't know which one is dependent, you might put the wrong thing on the y-axis. So do you think the pay depends on the length of the show or the length of the show depends on the pay? Go ahead.
Pay first.
Pay first. Pay depends on the length of the show. So the dependent variable is the pay or money or fee or cost for the show, however you want to put it. The independent variable is the time or the length of the show, and that's in minutes. Because the pay depends on the time. So we're going to start plotting these points now. So you have the table in front of you. I'm going to ask for your help a little bit because I don't have the numbers right in front of me. But I think for 15 minutes, which was here, I believe it was $75. Am I right? We'll just look back. Yep. And the nice thing is, once you've established it's a constant rate, you don't have to keep looking back at your data. And I can see all of you plotting in the points. Which tells me that you understand this idea, that it's 15 more minutes and it's $25 more. It's 15 more minutes and it's $25 more. And it continues up in that regular pattern. And we are going to go up to, that's 105, let's go up to 120. And let's assume that that's the longest show the magician is willing to put on. Otherwise, it's too long. People lose interest. Even 2 hours would be too long. So, question for you guys. Ryan, is it linear? Is this a linear pattern? In other words, would these dots fall in a straight line? Yes, it is linear. Good. It's linear. Is it a direct linear relation? No. Why not?
Because it doesn't come from the origin.
It doesn't come from the origin. If we drew them, it wouldn't go to the origin. Drew the line. Now, Alexa, I'm going to ask, it's Alexa, right? I'm going to ask you this question because we've talked about this before. Do you think I'm allowed to connect the data points?
No.
I would agree with you. I would say no. Because I think what the magician's going to do is charge based on this. If he has a show for, let's say he has a show and it ends up being 68 minutes, he's going to charge $175. It's more than 60, so he's there for at least the next 15. We're always going to be charging based on clumps of 15 minutes. So it is linear though. So how do we handle this? How do we draw a line, because it's linear, that doesn't include the space in between the points? And the answer is, and you will need a ruler for this, there you go. You got one? Okay. The answer is we draw a dotted line. If it's a solid line, we're saying it can be anything in between. If it's a dotted line, we're saying it's just the data points. But the line itself still is important. Now I have a question for you. Once you've drawn that in, I'll give you just a minute to finish. Can I do this? Definitely. If I'm a magician and somebody books me for a 45-minute show and I start putting work into the show, I start getting all of my material together, I buy a few supplies because I know I'm going to need whatever, balloons because there's going to be children there and I make balloon animals, I don't know. And I start getting the show together and this person phones me back the next day and says, you know what? Sorry, we don't need you anymore. I'm going to charge them $50 for my time. So you should include 0 here. So that's what the graph looks like. It's linear, but it's not direct because it doesn't go through the origin. Is the fee compared to the length of the show a direct linear relation? Well, we've already answered that. There are 2 boxes that have to be checked. If you look up here, please, there are 2 boxes that have to be checked for it to be direct linear relation. Does your graph contain dots that are in a straight line? Yes. Does your graph go through the origin? No. Which means it's not a linear, it is a linear relation. It's not a direct linear relation. So, although it's linear, although it is linear, the relation is not direct. It doesn't pass through the origin. And we know it doesn't pass through the origin because if the show is 0, you still get charged $50. You don't pay 0 for a 0 length show. If you cancel, you're still on the hook for 50 clams. Now, what's the slope of the line? What's the significance of the slope? Well, I've got the graph up here. To find the slope, again, we've done this for 3 days now. How many of you prefer to draw a triangle? How many of you prefer just y minus y over x minus x? That's the preference, but we're going to do both. The slope is equal to y2 minus y1 over x2 minus x1. This formula, everybody, is from Math 20-3. And it would be on your formula sheet that you have for exams in this class. So all you need to do is take 2 points. And I think I just saw somebody circling 2 points. Daniel, is that what you were doing? You were circling 2? Let's use the ones that Daniel's using. Daniel circled this one, correct? This one?
Yeah.
Okay. Does it matter which points we choose? Shouldn't, because it's a straight line. The slope should be the same no matter what, but we're going to use those 2. And I'm pretty sure you like the y minus y over x minus x dealie. So I'm going to write the coordinates of this. This is 105, comma. Remember, these go up by 15. 105, comma, and these go up by 25. 225. And this one would be 15. Your x coordinate comes first, then comma 75. How many of you, by a show of the hands or a nod of the head, when I say, do you prefer the triangle or the y minus y over x minus x, how many of you say, well, they're really the same thing? That it doesn't really matter which way you look at it? No? A couple of you. Some of you just want to use one method. So we're going to do y minus y over x minus x. Y, so that's 225. Right? 225 is a y coordinate. Minus 75 is the other y coordinate. Over, we go x, which is 105, minus x, which is 15. Let's see what we get. Elijah, let us know what we get for the top when you subtract. 150? Okay. So we get 150 over, Ryan, what'd you get for the bottom here? So when we're just subtracting here 105 minus 15. I'm just looking at just the bottom of this expression, not the whole thing yet. 90. Okay. 90. Now, what is that 150? 150, like banana daiquiris? 150 lizards? 150 what? Alexa, what are the units of that rise? So what are we measuring here this way? It's dollars. So this is dollars. And what are we measuring horizontally? Minutes. So this is going to be dollars per minute. I think it's 1.6666. Is that right? So we're not going to worry too much about rounding and exact values in this class. The slope is about $1.67 per minute. So what does that mean? You cannot tell me what the slope means unless you look at the units, right? And what it means is it's $1.67 per minute. Once, if I'm the magician, once I get the show started, every minute that goes by, cha-ching, that's another $1.67 that's going to go into my pocket. So 167 for each minute. If you want to not use that formula, and I get it, I get that some people don't like this formula that's in the top left corner of the screen. It's ugly. Then what you would do is this. You wouldn't even need to write down these numbers. You would draw a triangle that looks like that, and you would write down, by figuring out what this is, you'd look over here, that's 75. You'd look over here, this is 125. You'd subtract those numbers, 125 minus 75, 225 minus 75. Is 150. And here you would take 105 minus 15, which is 90 minutes. Well, surprise, surprise. That's what we did. It's just that we did it on the graph instead of up here with the equation. Any questions with the graph or finding the slope? Right? What's the significance of the y-intercept? So first of all, and I've taught this before to students, and you have a hard time, not you in particular, but students in this course usually have a hard time with what the y-intercept means. The y-intercept is where the line crosses the y-axis. So I'll remind you, should know this, but you never know. This is the y-axis. So look at your graph, please. What is the y-intercept? Where does your graph cross the y-axis, Ryan? In other words, what number is it at on the y-axis where the line touches it? Is it at 100? Is it at 200? Is it at 25? Where is it?
0.
Does your graph, remember this is 0. I'll go back and I'll show you our graph here. Whoops. I want that point there. It doesn't matter. I'll just draw it in. This is 0. So that's 0 for y. This is 100 for y. If it did have a y-intercept of 0, then the line would be going through the origin. So what we're looking at here is this. That's the y-intercept. It's where it touches the y-axis. So Daniel, what is it?
50.
It's 50. So, and again, this is a tough thing. But let's write down the answer, and then we'll do some more practice with it. So, since it looks like that, and this is $50, the y-intercept is equal to $50. And remember what I've told you a couple of times in this class. If something's easy for you, that's fine, but I want everybody to understand it. And this is tricky. It's not simple. If I had this graph, totally different graph, 20, 40, 60, and the line looked like this, I would like everybody to estimate what the y-intercept of that line is. And I'll give you a hint. If that's 20 and this is 40, this is 30. What do you think?
About 25, 26.
25.6?
25 or 26.
Oh, 25 or 26? I would be in agreement. I would probably go closer to 26, because 25 would be halfway between 20 and 30. If you said 27, anybody think 27 in their head? That's fine. We're not, launching rockets and landing people on Mars here. It doesn't have to be perfect. So this y-intercept would be about 26. We'll split the difference. Some of you said 26, some said 27. Let's go 26. So does everybody understand what the y-intercept is? Like how you find it on a graph. It's just where the graph crosses the y-axis. Okay, good. So what is the significance of this? Well, I know this is tricky, but I want to point out to you that this is 0 as well. So the coordinates of this point, which is the y-intercept, there's an x-coordinate of 0 minutes and a y-coordinate of $50. So why is that y-intercept $50? Because that's the flat amount. And every single question you ever do that has a fixed amount or a flat amount, the y-intercept will be that fixed amount. So this is the flat whoops, the flat fee. I got a question for you. And you know me by now, even though you've only been in this class a few days. Sometimes I go off road here. We got this nice lesson that I've typed up for you. We're going through it. But I'm going to go off road. I'm going to take a detour. Last week on Wednesday, Brennan gave us the example of the logs. Remember that? And he said the weight here and the number of logs here. And in fact, I talked about this example probably on Thursday of last week and on Friday of last week because it's a perfect example to illustrate a point here. We were talking about graphs when Brennan brought this up that went through the origin, right? And I asked for examples of situations, and Elijah, you gave me the example where somebody was fixing cars and it was $200 per car. Remember that? So, and I asked Brennan, when you said the weight, is that the weight of the logs or the log in the truck? And I asked everybody, and I think Daniel said, well, it has to be just the logs. I don't know if you remember saying that.
I made the point when we were talking about where it wouldn't be on the zero.
Right. So if we did include the truck, it wouldn't be at zero. Okay. Well, what if we include the truck now? That would mean when there's zero logs, when there are zero logs, there's a certain number of kilograms for the weight, right? Maybe it's that. So the y-intercept here would be 14,500 kilograms. Are you guys still with me here? What's the significance of that? It's the starting point. It's the weight when you haven't loaded any logs on yet. Just like the y-intercept in our example is the pay even though I haven't done anything yet. It's the beginning value. So this would not be direct variation. Okay. So we've completed the graph. What's the significance of the y-intercept? We've already done that. Now, let's turn the page, please. Linear relations like this one are called partial linear relations, and you need to know this. Okay, I've got a picture I'm going to show you here in a second. When the graph is linear because it's a straight line, but it does not go through the origin, it's a linear relation, but it's partial, not direct. Partial is the word. Partial linear relations, the dependent variable is found using a fixed amount and a variable amount. So, the fixed amount of $50 plus the $25 per 15 minutes, which changes depending on how many minutes you perform. With Brennan's example, the fixed amount would have been the logging truck, and the variable amount is the weight of all the logs put on it. The graph of a partial linear relation does not go through the origin. So, remember I started off the lesson by showing you this? Well, that's partial. We still put the dependent variable on the vertical axis. We still put the dependent variable for y. We put the independent for x. We still say y compared to x. We are still comparing the dependent compared to the independent. But it's a straight line that does not go through the origin. See, the difference is this, and I'm going to come up with a different example here. Now, let's stick with the example we just did. If this is the pay for the magician, and this is the time for the magician, and this is $50, and then I go over here, and I look at this point, and I'm going to go flour, grams of flour, and number of cookies was what we did, right? Because the amount of flour you use depends on how many cookies you make. If I decide to make 50 cookies, I use a certain amount. It depends on the number of cookies. So this is at 0, 50. This is at 0, 0. Let me explain this in words. I get hired to do a magic show and they cancel, so the show is 0 minutes long. There is still an amount I get paid. Okay? I decide to go home tonight and make cookies, and then you know what? I change my mind. Then that means I'm not making any cookies. I don't need any flour. There's a big difference here between the two. Does anybody have any questions about the difference between these two types of relations? All right, we have one more example we're going to do today. Then you will have some problems from your textbook and handout to do. And if you were away on Friday, you have that assignment, which I'm going to take in tomorrow. For those of you that already turned it in, I just haven't marked it yet, but you will get it back tomorrow. Okay? So Loris is a plumber. When he makes house calls, he charges $45 plus $35 for each hour of work. Which of those numbers, 45 or 35, is the fixed amount? 45. It's going to cost you $45 for him just to walk in your door. He comes in, you say, you know what? I fixed it myself. He will say to you, okay, you'll get a bill in the mail. And you'll go, what for? You didn't do anything. Well, I came over here, and that's time is money. I mean, if you're a tradesperson, you get paid for that. It's not just the time you do the work; it's the time driving there, because that is work. And then $35 for each hour of work. So we can put here, when we complete the table, that this is $45. For some reason, I don't know why, it's hidden. That's weird. There we go. That's the earnings, $45. Now, just like Daniel pointed out with the money that the magician was getting, this is going up by 1 hour each time. So since it goes up by 1 hour each time, and he gets paid an additional $35, you need to complete the table by adding 35 and adding 35. And I'll give you a minute to do so, please. I'll see how I do here. You check your calculator work against what's popping out of my brain. How did I do? Good? Okay, so we got that part done. And everything we've done in this course so far is about making tables, making graphs, finding slopes. Now we are adding the y-intercept. So we've got that done. Complete a graph of the data. So what do we need to add to this graph? What's not on this graph that's in your notes that we have to have? I mean, we've got to plot the data, but even before we do that, there's some things we need to include. Alexa, do you have one? What's something we got to add to this before we can start putting data on there? Numbers. We need numbers. And that means, by the way, we have to as well know what we're plotting where. And we're going to plot earnings on the vertical axis because the pay depends on the number of hours. And that means the number of hours is the independent, and we also need a title. And by the way, You know that that has to happen first. You know that you have to put the numbers on before you plot data. Now things get a little bit ugly here, okay? Not that bad, but just a little different than every other graph we've done. And it's because, look at our numbers. I've reproduced the data table here. We have to scale this graph so that it goes up to 5 hours, and that's easy. That's easy, right? We are going to go 0, 1, 2, 3, 4, 5. No problem. And we want to scale the vertical part of the graph, though, to go up to at least 220. And that's not bad either. I think the best thing to do, and just look up here before you start writing anything, is to say, if I said that's 50, then we would have 50, 100, 150, 200, 250. It doesn't land on 220, but it goes up past 220, so that's a good scale. All right? So we can put 50 here, 100, 150, 200, 250. But now comes the tricky part. The tricky part is this. If you look at the first data point, 0 for x and 45 for y, do you know exactly where that data point is? Is there a line there at 45? There isn't. You don't know where these data points are exactly. In other words, you have to estimate where you would put them. But let's just drop this for a second and look up here. I want to take us back to the cookie problem, top left corner. I asked you all, and you all figured it out eventually, why is this linear? And everybody came to the conclusion that it's linear because this is going up by 10 each time, and this is going up by the same amount each time. I'm not saying it's going up by 10. I'm saying every 10 addition to x, you get 40 being added to y. So as long as those lumps kept increasing by the same amount, you knew it was linear, right? So now I have a question for you. If you know a graph is linear, then how many points do you really need to plot to draw the graph? If I know they're going to fall in a straight line, do I need to plot every point? How many can I get away with plotting? If we go back, well, first of all, is this linear? Up by 1, up by 1, up by 1, up by 35, up by 35. Yeah, that's linear. The magic show was linear for the same reason. I have a question for you. Let's go back and look at the graph for the magic show. Would you have been able to draw this line if you only knew those 2 points? Sure, because it's a straight line. In other words, we only need 2 points to draw the line. So when we plot this, why don't we just plot the 45, and I think 45 is about here. I noticed that many of you plotted it already because I can see some of you erasing it and replotting it. It's pretty close to 50. And this data point is a nice one to use, 3, 150, because it's not 80 or 115. So at 3, we can put a data point at 150, and then draw our line. How many of you are going to go into the trades after high school? Okay. You're not going to be paid, if you're in this kind of situation, you're not going to be paid for part of an hour. You're going to be paid for the full hour. If you start work at noon and you finish at 2:15, you're probably going to charge for 3 hours. It's not going to be that way, where you get money each minute, which means when we draw this, we probably shouldn't use a solid line. So you're going to draw in this data, this line. You know, maybe some tradespeople charge by the quarter hour. But that, we don't need to worry about that. That's not what's important here in this lesson. So that's what the graph looks like. All right, I think you know where this is going. What's the slope? What's the y-intercept? Tell me about the slope and the y-intercept. Find the slope of the graph. So I've got a better graph here. I have more data here. You don't. I think what you have is that, right? So how are we going to find the slope? Well, I'm going to do the triangle thing here. This is 150 minus 45. It's the vertical height, right? So this is 150 here. This is 45 here, so you have to subtract them. This is 3 minus 0. I hope you're getting better at the slope thing. I think it's easier now than it was when we first started. So what does that work out to? I think that's $105. And this is 3 hours. So our slope is the rise over the run. Can you work that out for me, please? How many of you know what you're going to get? You're going to get $35 per hour. Right? That's what Loris is getting paid. So what does it mean? I think we can shave a bit of time off the lesson here. I don't think we need to write this out. It means that every hour he works, he gets paid $35. And I think, finally, what's the y-intercept? So what is the y-intercept of this graph? Ryan, do you know? 45. You nailed it. You got it. $45. What does it mean? Why is the y-intercept $45? That's a tougher question. So we know the y-intercept. Whoops. The y-intercept is $45. Can anybody tell me what it means? Elijah, do you know? Why is the y-intercept $45? Why does it start at 45? That's $45 is the pay for the job no matter what. That's the fixed cost. So again, this is always the starting amount. The weight of the truck with no logs on it. The charge for the show without any tricks. In this case, the charge for the plumbing without actually doing any hourly work. So this is the fixed cost. One last question, and this question, everybody, is leading up to tomorrow. This next question is not that big of a deal. If it was an 8-hour call, man, oh man, things must have been really bad if a plumber is going to be in your house for 8 hours. like you had leaks everywhere. Or you're replacing all the faucets in your house and replacing the hot water tank as well. It could be 8 hours. How much will he charge? Well, it's going to be $45 plus 8 times 35, because each of those hours is $35. So we can answer this question. I'm getting 325. You getting that as well? Okay, 325. The big difference here, everybody, compared to direct linear relations is right there. The slope still found in the same way. Now there's a y-intercept as well. Let's see, what have I got here? You know what? I think that's good enough. On page 25 of your textbook, number 7, on page 18 of the unit handout, which is the thing you have in front of you, number 7 as well. If you need graph paper, maybe you want graph paper just because the graph paper in your unit handout is pretty small. There's some graph paper here. You have rulers. I'm going to hand out the assignment that was due today. If you were absent last day, it's due tomorrow. Okay. It's praise, right? Okay, there you go, praise. And you know, I want this assignment turned in tomorrow, so if you have a really good idea of what we did today, then get started on this assignment. But this assignment, all the lines will go through the origin. Okay? Not here. Do you have a question? Yeah. Hazel's not here. And I'm just checking. I'm pronouncing your name right, correct? Okay. Same thing, Ryan and Elijah. If you have a really good handle on what you're doing today, I think the assignment is more important because I need that in tomorrow. If you don't get it in tomorrow, then you would get 0, and assignments are worth a quarter of your mark. So if you have questions with the assignment, let me know.